We've stared at the moon for thousands of years, a glowing companion watching over our nights, rising silently above mountains, deserts, and seas. It has been our calendar, our compass, our muse. Poets wrote about its light, sailors trusted its rhythm, and lovers found meaning in its glow. Yet despite all the times we've looked up, despite the countless nights humanity has spent beneath its watchful eye, there is one simple truth that has always remained unchanged. No matter where you stand on Earth, no matter when you look at it, you will always see the same face of the moon, the same craters, the same patterns, the same half. But why? Why have we never, in the entire history of human existence, seen the other side of our closest celestial neighbor? For centuries, that mystery haunted the human imagination. Ancient civilizations gazed at the moon and wondered what lay beyond its shining face. The Greeks believed the hidden side was the home of gods who watched the world unseen. In Chinese legends, spirits and moon rabbits were said to live there, thriving in an eternal darkness where the sun never reached. Even in modern times, the phrase "the dark side of the moon" has carried an eerie sense of the unknown, a place unseen, untouched, and perhaps unreachable. But that phrase is actually misleading, because the truth is, the far side of the moon isn't dark at all. It receives sunlight just like the side we see. It simply never turns toward Earth. The reason for that is one of the most beautiful gravitational dances in the cosmos. Imagine, for a moment, that the moon is not just orbiting the Earth, but also spinning on its own axis, just like our planet does. Now here's the catch. The moon takes about 27 days to complete one orbit around Earth, and it also takes 27 days to complete one full spin. These two motions happen at exactly the same rate. So as it circles us, it rotates in perfect synchrony, always keeping one face pointed toward us. This phenomenon is called synchronous rotation, or more poetically, tidal locking. It's as if the Earth and Moon are performing an endless dance, where the moon always faces its partner, never breaking eye contact. What appears static to us, that constant face in the sky, is actually the result of billions of years of gravitational choreography. Long ago, when the moon was still young, it rotated much faster. But Earth's gravity, pulling ever so slightly stronger on one side of the moon than the other, began to slow its spin. Over millions of years, this gravitational tug created friction inside the moon, gradually draining its rotational energy until it synchronized perfectly with its orbit. When that happened, the locking was complete. The moon found its balance point where one hemisphere would forever gaze upon Earth while the other would forever look away. It's a dance frozen in time, motion and stillness both existing at once, and here's the fascinating part: the dark side is not truly dark. In fact, it gets as much sunlight as the near side does. When we see a full moon shining in the night sky, the far side is facing the blackness of space, bathed in sunlight we cannot see. It's only dark in the poetic sense. Dark to our eyes, dark to our history. Dark because for millennia it remained unseen. It wasn't until 1959, when the Soviet spacecraft Luna 3 first photographed it, that humanity laid eyes on that mysterious terrain. What those images revealed was stunning. A world far rougher and more cratered than the side we know, scarred by billions of years of cosmic impacts, untouched by the gentle tidal forces that have smoothed the near side's face. Since then, spacecraft from NASA, the European Space Agency, and China's Chang'e 4 mission have mapped and even landed on the far side. It's a place of radio silence, shielded from Earth's interference, so silent that astronomers dream of placing telescopes there to peer deeper into the universe than ever before. The far side of the moon, once the most mysterious place we could imagine, has become a frontier of discovery. And yet, despite all our technology, there's something humbling about the fact that no human being standing on Earth has ever seen it with their own eyes. Every moonrise, every full moon, every lunar eclipse, we are looking at the same face our ancestors did tens of thousands of years ago. The other side remains hidden, a reminder that even our nearest neighbor holds secrets just out of reach. In the end, the moon's mystery isn't about darkness or secrecy, it's about balance. It's a story of motion, gravity, and time, all working together to create a perfect harmony between two celestial bodies, Earth and Moon locked in a silent waltz, bound by invisible threads of gravity. One turns, one follows, forever facing, forever orbiting, partners in an eternal dance. So the next time you look up at the night sky and see that familiar glowing circle, remember this: the moon isn't hiding from us. It's simply moving in perfect rhythm. A cosmic reminder that not everything unseen is lost in darkness. Some things are just quietly dancing beyond our view. The reason we always see the same side of the moon is a result of a fascinating natural phenomenon known as tidal locking. To understand it, we have to go back to how the moon and Earth interact with each other through the force of gravity. Gravity doesn't just hold the moon in orbit, it also constantly pulls on it, stretching and tugging on the rock and metal that make up its surface. In the early stages of the moon's history, billions of years ago, the moon rotated much faster than it does today. Back then, different sides of the moon would have faced Earth over time, just like how all sides of Earth face the sun as it spins once every 24 hours. However, because the moon is not a perfectly rigid body, the gravitational pull from Earth created small but continuous distortions on its surface, slightly stretching the moon in the direction of Earth. This distortion created something called tidal bulges, and as the moon rotated, these bulges tried to align themselves with Earth's gravity. But because the moon was spinning faster than it orbited, the bulges were always a bit ahead of the Earth-Moon line. Over time, these misaligned bulges acted like natural brakes. The gravitational attraction between Earth and those bulges created a torque, a twisting force, that gradually slowed down the moon's rotation. This process took millions, even billions of years, but gravity is incredibly patient. The energy lost from the moon's spin didn't just vanish. It was transferred into heat within the moon's interior and also slightly altered the moon's orbit, pushing it farther away from Earth at a slow rate of about 3.8 centimeters per year. Eventually, the moon's spin slowed down so much that it reached a point where it rotated exactly once per orbit around Earth. That means for every full circle the moon makes around our planet, it also completes exactly one full turn on its own axis. The two motions, rotation and revolution, became perfectly synchronized. This state of synchronization is what we call synchronous rotation or tidal locking. Once tidal locking was achieved, the moon effectively froze in this balanced state. Now the same hemisphere always faces Earth, while the opposite side, often called the dark side or more accurately the far side, never faces us directly. From our perspective on Earth, it appears as though the moon doesn't spin at all. But in reality it still does. Its rotation is just perfectly matched with its orbit. You can think of it like this. Imagine holding a tennis ball in front of you and walking around a circle while keeping one side of the ball facing your face the entire time. The ball is both rotating and orbiting, but because the two motions are synchronized, you always see the same side. The moon does exactly that. It turns just enough to keep the same face toward Earth through its entire journey. This locking mechanism doesn't only happen with our moon. It's actually a common outcome in the universe. Many of the moons in our solar system, like Pluto's moon Charon, Jupiter's major moons, and many of Saturn's, are also tidally locked to their planets. Even in binary star systems, one star can become tidally locked to another. The process is governed purely by physics. When two objects orbit closely enough for gravity to exert strong differential forces, pulling harder on one side than the other, the smaller one eventually slows its spin until its rotation matches its orbit. What makes Earth's moon so iconic, though, is that we experience this lock directly. We see the result with our own eyes every night. So when we say the moon shows us only one side, it's not because it refuses to rotate, it's because it rotates in perfect harmony with its orbit around Earth. This balance isn't fragile, it's incredibly stable. Unless something massive were to disturb the Earth-Moon system, the moon will remain tidally locked forever. Over billions of years, the interaction between gravity, energy, and motion reached a kind of equilibrium, one that we now see as a constant, unchanging face in our sky. And what's more fascinating is that the same gravitational forces that locked the moon's rotation are still influencing it today, keeping its orientation steady, even as it drifts slowly farther away from us. So, the next time you look at the moon and recognize its familiar craters, the Sea of Tranquility, Tycho, and Copernicus, remember that those features are permanently facing us because of a dance that began over 4 billion years ago. The moon's hidden face isn't dark by nature. It's simply the half that has been locked away by the slow but relentless power of Earth's gravity. The phenomenon is not magic, not myth, but a perfect demonstration of how balance, time... The term dark side of the moon has been used for decades, in songs, in movies, in books, and in everyday conversation. But it's one of the biggest misconceptions in all of astronomy. The far side of the moon, the half that never faces Earth, is not permanently dark. In fact, it receives just as much sunlight as the side we see. The confusion comes from our limited perspective. Because the moon is tidally locked, we on Earth never see that far hemisphere directly, giving the illusion that it's trapped in eternal night. But if you were standing on the moon itself, you would notice that both sides experience day and night cycles just like Earth does, except much longer. A full lunar day, meaning one complete cycle of sunlight to darkness and back again, lasts about 29.5 Earth days. That means when the near side is lit up and visible to us as a full moon, the far side is actually experiencing daytime, flooded with sunlight. 2 weeks later, when the moon becomes new and invisible to us, the far side is in total darkness, experiencing its night. So rather than being truly dark, the far side of the moon is simply the far side, hidden, not shadowed. It was only our lack of visibility from Earth that made it seem mysterious for so long. For most of human history, no one had any idea what that hidden hemisphere looked like. Ancient observers could map every crater and mare, the large dark plains formed by ancient lava flows, on the near side, but the far side remained completely unknown, until the middle of the 20th century. That changed in 1959, when the Soviet Union's Luna 3 spacecraft became the first human-made object to travel around the moon and photograph its far side. The blurry, grainy black and white images it sent back were revolutionary. For the first time in history, humanity saw the face of the moon that had been invisible since the dawn of time. Those first pictures surprised scientists. The far side looked dramatically different from the side we're used to seeing. The near side of the moon, the side facing Earth, has large, smooth, dark regions called maria, which are vast plains of solidified lava that formed billions of years ago when the moon's crust was thinner on that side. The far side, however, appeared heavily cratered, rugged, and mountainous, with almost no maria at all. This asymmetry puzzled scientists and led to decades of study to understand why the two sides were so different. Later data, collected by missions like NASA's Lunar Orbiter, Apollo, and more recently, the Lunar Reconnaissance Orbiter, LRO, revealed that the moon's crust on the far side is much thicker than on the near side, perhaps because of how the moon formed. One leading theory suggests that after the moon's creation, heat from the still molten Earth kept the near side warmer, while the far side cooled faster, leading to the thicker crust we see today. That difference in temperature may have prevented lava from flowing freely on the far side, which is why it looks older, rougher, and more cratered. For many years after Luna 3, the far side remained mostly a mystery because it's impossible to communicate directly with spacecraft on that side from Earth. The moon itself blocks all radio signals. Any mission exploring the far side has to rely on relay satellites orbiting the moon to send data back. But despite this challenge, humanity eventually reached it. In 2019, China's Chang'e 4 mission made history by becoming the first spacecraft to successfully land on the far side of the moon. Using a relay satellite named Queqiao, it transmitted data and stunning high-resolution images of the hidden hemisphere. The lander and its small rover, Yutu-2, discovered new details about the composition of lunar soil, the effects of cosmic radiation, and even hinted at the possibility of valuable resources like helium-3, a potential future fuel for fusion energy. These modern missions have shown us that the far side of the moon, once feared and romanticized, is one of the most scientifically valuable regions in our celestial neighborhood. Its radio silence, the fact that it's shielded from Earth's constant electromagnetic noise, makes it an ideal place to set up radio telescopes for deep space observation. Scientists dream of placing large, sensitive antennas there to listen to the faintest whispers of the early universe, signals from the first stars and galaxies that we can't detect from Earth. The far side could also become a key location for future space exploration bases, as it offers unique geological features and a natural shield from Earth's interference. But even with all our scientific progress, The far side still carries an air of mystery, partly because no human has ever seen it in person. All astronauts who have traveled to the moon, including those from the Apollo missions, have orbited it and briefly glimpsed the far side from above, but never set foot on it. For the few minutes each orbit that they passed behind the moon, they experienced something haunting: total radio silence. In that moment, they were completely cut off from Earth. No voices, no telemetry, no connection, just the dark, distant side of the moon hanging over an infinite void. For those astronauts, it was both terrifying and awe-inspiring. The phrase "dark side of the moon" then isn't really about light at all, it's about perspective. From Earth it's dark because we can't see it. From the moon it's bright half the time. It's a lesson in how our understanding of the universe is limited by where we stand. What seems mysterious or hidden often isn't. We just haven't looked at it from the right angle yet. The moon's far side is a perfect example of that truth. A reminder that even our closest celestial neighbor still has secrets that took thousands of years to uncover. So, while it may no longer be dark in the literal sense, it will always remain symbolic, the unseen half of something familiar, the reminder that every bright face has its hidden side. Thanks to science, we now know that the moon's hidden hemisphere is not a place of shadows, but a world of light, history, and wonder, waiting patiently as it always has, on the far side of our gaze. From the outside, it may seem like the moon simply circles the Earth, a lonely rock bound by gravity. But the truth is far more poetic. What we're witnessing every night when we look up is not a simple orbit. It's a gravitational dance, an intricate, eternal waltz between two celestial partners, Earth and Moon, locked together by invisible forces of attraction, rotation, and time. Long ago, billions of years in the past, the moon didn't always show us the same face. When it first formed, likely from a colossal impact between the young Earth and a Mars-sized planet called Theia, it orbited our planet much more closely than it does today. Back then, Earth's rotation was much faster. A day lasted only about 5 or 6 hours. The newborn moon circled us quickly, completing one orbit in just a few days. Over time, their gravitational pulls began to influence each other in subtle but powerful ways. The moon's gravity tugged on Earth's oceans, creating tides, the rise and fall of the sea that we still witness every day. But what's fascinating is that these tides, though caused by the moon, also started to push back on it. Here's how. As Earth spun rapidly, the bulges of ocean water it carried were slightly ahead of the moon's position in the sky. The gravitational interaction between these tidal bulges and the moon acted like a brake, slowing down Earth's rotation very gradually, almost imperceptibly, over millions of years. At the same time, that same gravitational tension transferred energy to the moon, causing it to slowly spiral outward, farther and farther from us. Even today, the moon is moving away from Earth at a rate of about 3.8 centimeters per year, roughly the same rate your fingernails grow. It doesn't sound like much, but over millions of years, it changes everything. This slow cosmic tug-of-war led to what we now call tidal locking, a perfect balance where the moon's rotation period matched the time it takes to orbit Earth. Essentially, as the moon spun, Earth's gravity pulled harder on any part that rotated away, creating internal friction that gradually slowed the moon's spin until it matched its orbital period. Once that equilibrium was reached, the locking became permanent. Now every time the moon orbits Earth once, about 27.3 days, it also completes exactly one rotation on its own axis. That's why the same lunar face is always pointed toward us, as if frozen mid-step in this eternal dance. But this dance doesn't just affect the moon. It's also shaping the future of our planet. Because Earth is still slowing down, our days are getting longer, very slowly by about 1.7 milliseconds per century. Millions of years from now, days will last a little longer. The moon will be a little farther away, and their gravitational connection will grow weaker. Eventually, billions of years into the future, the system might reach a state where both bodies become mutually locked, with Earth always showing the same side to the moon, just as the moon does to us. If humanity still exists then, people on one side of the planet would see the moon fixed forever, in the same spot in their sky, while the other side would never see it again. It's a haunting yet beautiful fate, two worlds frozen in a cosmic embrace, orbiting together in silence. The Earth-Moon system is not just a curiosity of motion, it's one of the most delicate and vital relationships in the solar system. Without the Moon, Earth might not even be the world we know. The Moon's steady gravitational influence stabilizes our planet's axial tilt, which controls our seasons and long-term climate. Without that stabilizing force, Earth's tilt could wobble wildly over time, leading to chaotic climate swings that might make life as we know it far more difficult to survive. The Moon's gentle pull keeps our world steady, our days predictable, and our oceans alive with rhythmic tides that have shaped coastlines and life for billions of years. This dance, then, isn't just mechanical, it's cosmic harmony. Every rotation, every tide, every glimmer of moonlight on the sea is part of a timeless choreography that began long before humanity existed. And though we've studied it scientifically, it still feels profoundly poetic. The Moon is not a passive rock circling us. It's an ancient companion forever linked to our planet's fate. Its orbit writes the rhythm of our oceans. Its pull slows the heartbeat of our world. And its face, and always turned toward us, reminds us that even in the vast cold of space, some connections never fade. So the next time you see the Moon hanging silently in the night sky, remember this: you're not just looking at a distant object. You're looking at the partner in Earth's eternal dance, a slow, graceful motion written in the fabric of time itself, a dance that began in fire and impact, yet continues in perfect, unbroken balance, the kind of harmony only the universe could compose. As eternal as the Moon may seem hanging in the night sky, even this celestial partnership is not forever. The Earth and the Moon, bound together by gravity for more than 4 billion years, are slowly, silently drifting apart. It's a separation so gentle that we'll never notice it in a lifetime, yet across the ages, it will reshape the rhythm of our planet, our skies, and even our sense of time. Right now, the Moon is moving away from Earth at about 3.8 centimeters per year. That's roughly the width of a human thumb, but in cosmic terms, it's a steady migration. Over millions of years, those small steps add up. Hundreds of millions of years from now, the Moon will be thousands of kilometers farther away than it is today. Its gravitational pull will weaken ever so slightly, and with it, the tides that shape our oceans will lose some of their strength. The powerful tidal surges that once sculpted Earth's coastlines will become calmer, gentler, more subdued. Future shorelines may see tides that barely whisper where today they roar. As the Moon drifts outward, the balance of motion between Earth and Moon continues to shift. Remember, their relationship is a constant exchange, a trade of energy between rotation and orbit. The same tidal forces that slow Earth's spin are the ones pushing the Moon away. So as the Moon climbs higher into space, Earth's rotation continues to slow down, making our days gradually longer. Billions of years from now, one Earth day will last more than 1,000 hours, longer than an entire modern month. The change is subtle, unfolding on scales far beyond human imagination. But in the clockwork of the cosmos, it's as natural as a heartbeat, and this growing distance will change the way we see the sky. The Moon, which once loomed huge and close in ancient times, will appear smaller and smaller. Today, it's perfectly sized in our sky, about 400 times smaller than the Sun, yet 400 times closer, which is why we experience total solar eclipses. Those rare and beautiful moments when the Moon passes directly between Earth and Sun, perfectly covering its light, are one of nature's most breathtaking alignments. But this perfect coincidence won't last forever. As the Moon continues to drift away, it will no longer be large enough in our sky to fully cover the Sun. In about 600 million years, total solar eclipses will cease to exist. Instead, future observers, if any still remain, will only witness annular eclipses, where the Moon passes in front of the Sun, but leaves a thin, blazing ring of light around its edges. The last total solar eclipse will mark the end of an era, the close of a chapter in the story of Earth's skies. Humanity, or whatever civilization exists then, will look up and see the same Moon we know, but just a little smaller, a little farther, a ghost of its former closeness. But this story stretches even further. As Earth's rotation continues to slow and the Moon drifts away, the system is slowly moving toward a double tidal lock, a state of final balance. In this far future, the Earth's rotation period will match the Moon's orbital period exactly. That means one side of Earth will permanently face the Moon, just as one side of the Moon always faces Earth. If you were on that side of the future Earth, the moon would hang motionless in the sky, never rising, never setting, just suspended in eternal stillness. On the opposite side, the moon would never be seen at all. The world would be split, one hemisphere living under the eternal gaze of its ancient companion, the other in endless absence. This mutual lock will take billions of years to form, likely longer than the remaining lifetime of our sun, because, far before that balance is achieved, our star will begin to change. In about 5 billion years, the sun will swell into a red giant, expanding far beyond its current size. As its outer layers reach out into space, they may engulf the inner planets, Mercury, Venus, and possibly Earth itself. The intense solar winds and gravitational changes will destabilize the moon's orbit, possibly even breaking the Earth-Moon bond forever. The moon could spiral away completely, lost into interplanetary space, or it could fall back toward Earth under the chaos of solar expansion, a final reunion in fire and collision, ending the story where it began. Yet before that distant fate, the moon will remain steadfast, luminous, and loyal. It will continue to rise over our world as it always has, guiding tides, marking months, and inspiring life. It will be there through the slow cooling of the planet, through the drift of continents, through the final sunsets of our species. Long after humanity is gone, long after cities crumble and oceans fade, the moon will still orbit in silence, a witness to everything Earth ever was. And perhaps that's what makes this relationship so hauntingly beautiful. The moon is not just a satellite, it's a mirror of time. It has watched Earth grow, watched life crawl from the oceans, watched civilizations rise beneath its glow, and it will watch as all of it fades. Its orbit is a story written in patience, in the language of eternity. So when we say the moon is leaving us, it's not a tragedy, it's the natural rhythm of the cosmos. Every bond in the universe, no matter how strong, eventually changes. But the memory of that bond, the harmony it created, endures. The tides will whisper its story, the stars will echo its silence, and the night sky will forever bear the mark of the companion that once danced with Earth, not as a farewell, but as a reminder of how beautiful connection can be, even across the endless cold of space. Since the beginning of time, the moon has been our companion, silent, constant, and unchanging, watching over us as we evolved from stargazing wanderers to beings capable of reaching for the stars. It has seen our entire story unfold beneath its pale glow. Every civilization that has ever lived has looked up and seen that same light, reflected off ancient dust that hasn't changed in billions of years. It's strange, isn't it? To realize that when you gaze at the moon, you're seeing something your ancestors saw exactly the same way tens of thousands of years ago, the same craters, the same glowing face, the same quiet mystery. But now, after centuries of curiosity, we finally understand what once puzzled humanity for ages, why we never see the moon's other side. It's not because it hides from us, or because it's dark or secretive. It's because of a balance, a perfect cosmic rhythm that has locked it in place. What seems like mystery is actually harmony, an elegant dance between gravity, time, and motion. The moon doesn't spin away. It simply moves in tune with the Earth, as if both were two dancers moving in perfect step, holding each other through eternity. And maybe that's what draws us to it, that silent perfection. It reminds us that even in the chaos of the universe, there are patterns, order, and beauty. The moon's slow rotation, its locked face, its endless orbit, all of it tells a story of balance, of forces finding peace in motion. In a way, it mirrors our own lives. We too revolve through time, facing only one side to the world, keeping parts of ourselves hidden, not in darkness but in quiet. We all have a far side, the unseen half of who we are, shaped by experiences, memories, and emotions that others may never witness. Just like the moon, our unseen side isn't dark. It's simply private, bathed in light that others can't see from where they stand. Throughout history, the moon has carried every meaning humanity could imagine. To some, it was a goddess. To others, a guiding lantern through the night. It marked the passing of months, the rhythm of the seas, the pulse of life itself. Farmers planted by its light, poets wrote by its glow, and lovers confessed beneath it. It has inspired music, mythology, and science alike. And yet, even after landing on it, even after touching its surface and leaving our footprints in its dust, we still look at it with the same sense of wonder, the same question that began our journey. What's out there? That's the beauty of the moon. It connects the most ancient parts of humanity. Our curiosity, our imagination, our hunger to know more. Every glance upward is a small reminder that we are not bound to this earth. The moon was our first step beyond home, the first proof that we could leave our cradle and reach into the vastness of the unknown. The fact that we've walked on it means that the universe is not beyond us. It's within our grasp. Yet even with all our technology and knowledge, the moon still feels mysterious, almost spiritual, as if it belongs both to science and to dreams. And when you think about its future, slowly drifting away, moving farther from us each year, it's hard not to feel a kind of cosmic sadness. One day, long after humanity is gone, the moon will be so distant that total eclipses will vanish forever. The night sky will still hold its light, but the perfect alignment, that brief moment when the moon and sun fit together like puzzle pieces, will be lost. It's a gentle reminder that even the most beautiful harmonies in the universe are temporary. Everything changes. Everything drifts apart. But that doesn't make it meaningless. It makes it precious. Because in every ending, there's meaning. In every slow drift, there's the memory of what once was. The Earth and Moon are bound by a story written in gravity, a story of creation, balance, and inevitable parting. And we, standing here beneath the same sky, are witnesses to one brief chapter of that story. For a few thousand years, we get to see the moon just as it is, perfectly placed, perfectly aligned, perfectly balanced, before time carries it onward. So the next time you look up at the moon, remember this: you're not just seeing a rock orbiting in space. You're seeing a mirror of our own existence, fragile, beautiful, temporary, yet full of meaning. You're seeing the silent witness to our entire journey, from the first spark of life to the rise of consciousness. You're seeing proof that even in an infinite universe, connections are possible, that something as vast as space can still feel intimate, familiar, and alive. The moon will keep orbiting long after we're gone. It will rise and set over empty oceans, over continents that no longer look like ours. But its story, our story, will live on in the tides, in the light it casts, and in the memory of every living being that ever looked up and wondered why. Because that question, that need to understand, to seek, to feel, is what makes us human. And the moon, our constant companion, has always been the mirror that reflects it back. When we talk about the moon, we often think of beauty, mystery, and motion, but we rarely think about how deeply it has shaped life itself. If the moon were suddenly to vanish, Earth would not just lose its most familiar light. The entire balance of our world would begin to unravel. For billions of years, the moon has been more than just a celestial ornament in our night sky. It's been an architect of stability, a silent sculptor guiding the rhythm of Earth's oceans, climates, and perhaps even life's very existence. Long before humans, before trees, even before fish, the moon was already pulling at Earth's oceans. That pull, the gravitational tug we call tides, became one of the most important environmental forces on our planet. In the ancient seas of Earth's early history, tides acted like a cosmic heartbeat. They pushed and pulled the waters in endless cycles, flooding and retreating across shallow shores. Every tide left behind small pools, rich in nutrients and exposed to sunlight, perfect nurseries for the chemical reactions that would one day spark life. Some scientists believe that the origin of life itself may have depended on these rhythmic tidal patterns, giving primitive molecules a chance to combine, split, and evolve in cycles of wet and dry. But the moon's influence didn't stop there. As life began to flourish, its gravitational presence gave Earth something most planets in the universe lack: stability. Our planet's axis, the invisible line around which we spin, is tilted at about 23.5 degrees. That tilt gives us our seasons. Spring, summer, autumn, and winter all exist because of that precise angle. Without the moon, Earth's tilt would wobble chaotically under the influence of other planets, especially massive Jupiter. Over thousands or millions of years, our tilt could shift wildly, turning frozen poles into tropical oceans and baking the equator into desert wastelands. Such instability would have made complex life nearly impossible. But the moon's steady gravitational hold keeps our tilt stable, gently rocking only a few degrees back and forth. Thanks to that, our climate remains balanced enough for life to evolve, adapt, and endure. In a way, the moon acts like a guardian, a cosmic anchor, holding Earth steady against the chaos of the solar system. It doesn't just create the rhythm of tides, it preserves the rhythm of life. The rise and fall of the oceans, the cycles of migration, reproduction, and even sleep in countless species are tuned, consciously or not, to the lunar cycle. For early humans, the moon was more than a light in the sky, as it was a clock, a calendar, and a compass. Its phases marked time long before we invented hours and weeks. Ancient people watched it wax and wane and built their lives around its glow, planting, harvesting, traveling, and celebrating under its light. The moon taught humanity to measure time by its reflection, to understand the passage of days, months, and years through something constant. Even our myths and beliefs are proof of how deeply the moon has shaped us. Every culture that ever existed has looked at it and seen meaning. Gods, spirits, omens, lovers. To the Egyptians it was Khonsu, the god of time and travel. To the Greeks, Selene, the goddess who drove her silver chariot across the night. To the Chinese, the moon rabbit, pounding the elixir of immortality. And for centuries we've celebrated its power, marking full moons with rituals, prayers, and festivals. Without even realizing it, we've been honoring a celestial force that quietly governs not only our tides, but the rhythm of our own hearts. But maybe the most profound connection of all is this. Without the moon, we might not even exist. Its gravitational pull didn't just stabilize Earth, it slowed our planet's rotation. When Earth was young, a single day lasted only a few hours. The moon's steady drag stretched those hours into days, giving the planet time to cool, for weather to form, and for life to adapt to the changing light. Without that slowdown, our climate might have been too violent, our winds too fierce, our world too unstable for evolution to take hold. In a very real sense, the moon gave Earth time, the time needed for complexity, for consciousness. For us, it's humbling to think that this silent sphere of rock, floating hundreds of thousands of kilometers away, has been shaping our fate since before we even had names for the sky. It doesn't speak, it doesn't move toward us, but every drop of ocean, every gentle wave, every sunrise and moonrise carries its invisible signature. The moon is a sculptor, not of stone but of rhythm. It has written the tempo of our world in gravity, a force that speaks in silence, yet resonates through every heartbeat of the planet. So, the next time you stand by the sea and watch the waves roll in, know this: those waves are echoes of the moon's touch. Every tide is a whisper from our ancient companion, calling across the void to remind us that we are not separate from the cosmos. We are part of its dance. The same dance that locks the moon's face to ours is the one that gave rise to life itself. In the moon's soft glow, we don't just see a distant world. We see the reflection of everything we are, everything we've become, and everything we owe to the quiet, powerful presence of our nearest neighbor in space. For thousands of years, the moon was untouchable, a glowing enigma in the heavens, close enough to see but far beyond reach. It was the first thing ancient humans ever truly wondered about, that soft silver light that followed them through, the dark changing shape night after night, whispering that there was more beyond the sky. In every corner of the world, every civilization looked up at the same moon and dreamed the same impossible dream. What if we could go there? The moon became humanity's first destination, not in reality, but in imagination. Before ships crossed, oceans or machines flew through the air. Poets, philosophers, and dreamers were already sending their minds to the moon. The ancient Greeks believed it was a perfect sphere, the realm of gods and eternal light. The Chinese imagined a palace of jade, where the immortal Chang'e lived in solitude. In the 1600s, Galileo pointed his telescope toward it for the first time and shattered the myth of perfection, revealing mountains, craters, and shadows. The moon, he discovered, was a world, another place real and reachable. That revelation changed everything. Humanity realized the heavens were not divine, untouchable realms. They were destinations. And from that moment, the idea of reaching the moon became more than fantasy. It became destiny. Fast forward to the 20th century, a time of rapid innovation, fierce competition, and unbridled ambition. As the world divided during the Cold War, the moon became more than a symbol of wonder. It became a prize, a stage for human achievement and for power. Two nations, the United States and the Soviet Union, raced toward the stars, each determined to prove not just their technology, but their vision of the future. The Soviets struck first, launching Sputnik in 1957, the first man-made object to orbit Earth. Then came Luna 2, the first spacecraft to reach the Moon, and Luna 3, which captured the very first photographs of its mysterious far side, the side humanity had never seen. For the first time in history, the unseen became seen. The Moon was no longer a distant light. It was a destination waiting to be touched. In 1961, standing before the world, US President John F. Kennedy spoke words that ignited a new era. "We choose to go to the Moon in this decade and do the other things, not because they are easy, but because they are hard." Those words became a spark, a promise to turn the impossible into reality. The following years were filled with danger, innovation, and sacrifice. Thousands of engineers, scientists, and astronauts dedicated themselves to a dream that was older than civilization itself. Rockets exploded, missions failed, lives were lost. But humanity pushed forward, one mission at a time: Mercury, Gemini, Apollo. And then, on July 20th, 1969, that dream became real. A fragile spacecraft called Apollo 11 descended toward the Moon's surface. The world watched in collective breathlessness as Neil Armstrong's voice crackled through static. "Houston, Tranquility Base here. The Eagle has landed." In that moment, thousands of years of myth, curiosity, and longing converged into one heartbeat. A human being, one of us, was standing on the Moon. When Neil Armstrong stepped onto the surface and spoke his immortal words, "That's one small step for man, one giant leap for mankind," the world changed forever. It wasn't just a victory for one country, it was a victory for the human spirit. For the first time, we had left our world and touched another. From that pale, dusty surface, astronauts looked up and saw Earth, not as nations, not as borders, but as a single glowing blue marble suspended in the void. That image, fragile, beautiful and alone, transformed how we saw ourselves. We realized we weren't just inhabitants of Earth, we were citizens of the cosmos. In the years that followed, 12 humans would walk on the Moon, each leaving footprints that may last for millions of years. They brought back rocks, dust, and data, but more importantly, they brought back perspective. The Moon was no longer unreachable. It was a place, real, tangible part of our story. Humanity had crossed the greatest divide imaginable, from dream to discovery. Yet after the final Apollo mission in 1972, we stopped going. The silence returned. The footprints remained undisturbed while Earth moved on. Decades passed, but the Moon never stopped waiting. It still hangs above us every night, ancient, patient, glowing softly as if to say, "You made it once. You can come again." And now, after half a century, we're returning. New nations, new technologies, new dreams, from NASA's Artemis program to private ventures like SpaceX and Blue Origin, humanity is once again reaching for the Moon. But this time, not just to visit, to stay, to build bases, study its resources and prepare for the next leap, Mars and beyond. The Moon, once the symbol of our limits, is now the key to our expansion into the stars. Our story with the Moon has come full circle, from mystery to understanding, from dream to reality, and soon from destination to home. The same light that guided our ancestors will now guide rockets, astronauts, and generations of explorers yet unborn. The Moon has always been more than a rock. It's a mirror of our ambition, reflecting back not what we are, but what we can be. It watched as we crawled from the oceans, learned to stand, learned to dream, and finally learned to fly. It has been the witness to our greatest fears and our greatest triumphs. And through it all, it has never stopped calling. A silent reminder that the human spirit was never meant to stay grounded. Because somewhere deep inside every one of us, when we look up at that glowing light in the night sky, we don't just see the Moon. We see possibility. We see the echo of every dreamer who ever dared to imagine more. And we know, no matter how far we drift, no matter how small we seem, we belong to the stars. For 50 years, the Moon watched in silence. The dust beneath the footprints of 12 astronauts remained untouched, fragile reminders of a time when humanity dared to dream beyond its cradle. As decades passed, technology evolved, nations rose and fell, and our attention shifted to other worlds. Yet every night the moon still hung there, unchanging, eternal, as if waiting for us to remember. And now we finally have. A new era of exploration is dawning, one not driven by rivalry or war, but by curiosity, cooperation, and survival. The moon is no longer a symbol of conquest. It's a key, the first step toward becoming a true spacefaring civilization. Scientists, engineers, and dreamers around the world are united by a single goal: return to the moon and stay there. Programs like NASA's Artemis are leading this revival. Unlike Apollo, Artemis isn't just about flags and footprints, it's about foundations. The plan is to establish a sustainable human presence on the moon by the end of this decade. That means building habitats where astronauts can live for weeks or even months, powered by solar energy, shielded from radiation, and supplied by resources found directly on the lunar surface. The moon's frozen poles, once mysterious shadows, are now our greatest hope, hiding vast reserves of water ice beneath the regolith. Water, the key to life, the source of oxygen and the fuel of rockets. In that ice we may have discovered the first building blocks of a permanent human settlement beyond Earth. Imagine it, glowing bases nestled within craters, shimmering, domes reflecting sunlight, rovers gliding across the surface like metallic ants. The first lunar cities won't look like science fiction. They'll be practical, rugged, built from lunar dust itself. Scientists are developing 3D printers that can transform regolith, the moon's fine grey soil, into solid structures, bricks, and landing pads. Instead of carrying materials from Earth, we'll build using what's already there. Humanity will adapt to its new environment just as it always has, by innovating. But this time, we're not going alone. Countries like China, India, Japan, and members of the European Space Agency are all preparing missions to the moon. Private companies, SpaceX, Blue Origin, Astrobotic, Ispace, are designing landers, habitats, and rockets that could make lunar travel as routine as flights to orbit. For the first time in history, the moon isn't just a destination for scientists. It's becoming an economy, a new world where nations and companies will work side by side, creating a foundation for the next leap into the cosmos. Yet, the goal of returning to the moon isn't only to explore it, it's to prepare for what comes next. The moon is the perfect training ground for Mars. It's close enough to Earth for help to arrive if needed, yet far enough that we must learn to be independent, to live off the land, to recycle every drop of air and water, to survive the harsh silence of space. The technologies we develop on the moon, closed-loop life support, radiation shielding, in situ resource use, will become the tools that carry us to Mars and beyond. The moon is our cosmic classroom, where humanity will learn how to live away from Earth, and there's more than just survival waiting there. The moon offers a scientific treasure unlike anything else, because it has no atmosphere, no weather, and barely any geological activity. Its surface preserves the history of the entire solar system. Every crater, every grain of dust is a time capsule billions of years old. Studying them could reveal how the Earth formed, how water arrived, even how life began. On the far side, forever shielded from Earth's radio waves, scientists dream of building powerful telescopes capable of peering deeper into the universe than ever before. Imagine seeing the birth of the first stars, the first galaxies, all from a silent observatory on the far side of the moon. But perhaps the greatest reason to return is something deeper, something emotional. The moon represents hope. For all our flaws, our conflicts, our struggles here on Earth, it reminds us that humanity is capable of greatness, that we can work together towards something larger than ourselves. When astronauts look up from the lunar surface and see Earth, that tiny blue marble floating in the black, they don't see divisions or borders. They see home. And maybe, just maybe, that's what we need to remember, that we are one species, sharing one fragile world, looking outward together. In the decades to come, the moon will become our second home. There will be astronauts who grow up training to live there, scientists who spend months studying its secrets, and perhaps even children who will one day be born under its pale light. Our descendants may look back and wonder how it felt to stand on Earth, gazing at the moon as something unreachable, because for them it will be a place as familiar as the continents are to us. And when that day comes, when we build cities on the moon, when lights flicker softly in lunar night, when human voices echo across the cratered silence, we will have taken our first true step into the universe. The moon will no longer be a symbol of distance. It will be a bridge, connecting our past with our future, our planet with the stars. We once looked up at the moon and saw mystery. Now we look at it and see destiny. For as long as humans have existed, the moon has been our mirror. It has watched us evolve, from creatures crawling out of the oceans to beings who dared to look up and wonder. It has been the silent witness to every chapter of our story. The rise and fall of civilizations, the birth of languages, the first fires, and the last wars. It has never spoken, yet it has always told us something. Something about who we are and what we're capable of becoming. When you stare at the moon, you're not just looking at a distant world. You're looking at time itself. Its craters are scars from the early chaos of the solar system, the same chaos that shaped our planet. The same impacts that struck the moon also struck Earth, and in that violence life found a way to emerge. The moon isn't just our companion, it's our sibling born from the same cosmic event that made our world. Billions of years ago, a young Earth collided with another planetary body, and from that explosion of molten rock, the moon was born. Ever since, it has orbited us like a guardian, influencing our tides, stabilizing our tilt, and keeping the rhythm of life steady. Without the moon, Earth as we know it might never have existed. No gentle seasons, no stable climate, perhaps no life at all. So when we gaze up at that glowing disk, what we're really seeing is our own origin story. The moon is a piece of Earth, flung into the sky and frozen in time, a reminder of both our fragility and our strength. It reminds us that from destruction, creation can rise, from chaos, order can emerge, and from isolation, connection can be found. But the moon's greatest lesson isn't about science, it's about perspective. It shows us how small we are and yet how significant. When astronauts stood on its surface and looked back at Earth, they didn't see nations, they didn't see lines, they didn't see us divided. They saw a single blue world, delicate, floating in the infinite dark. That image changed humanity forever. For the first time, we truly understood that everything we are, every love, every dream, every life, exists on that one fragile sphere suspended in the void. The moon taught us humility. It reminded us that while the universe is vast beyond comprehension, we are all part of it, connected by the same cosmic story. In its silence, the moon asks us to listen, not to the noise of the world but to the quiet truth inside ourselves. It asks us to remember that wonder is not something we outgrow, it's something we return to. Every child who looks up at the night sky and feels that spark, that question, that pull, is feeling the same thing our ancestors did 1,000,000 years ago. The same curiosity, the same awe, the same call to explore. That's what it means to be human, to never stop asking what's out there. And as we stand on the edge of a new era, preparing to return, to build, to explore deeper than ever, the moon continues to watch us. It has seen our worst moments and our greatest triumphs, and it waits patiently as we take the next step. It doesn't rush us. It simply shines softly as if to say, I've always been here, and I'll be here when you're ready. One day, generations from now, when humans live and work among the stars, when the idea of space travel is no longer extraordinary but ordinary, they will look back at this age, our age, and call it the beginning. The time when humanity stopped being bound to one world and started to truly belong to the universe. The moon will always be where that journey began. It's our first destination, our first lesson, our first reflection of what lies beyond the sky. It has shown us that mystery is not something to fear, but something to follow, that even in darkness there is beauty, and that no matter how far we go, we will always carry a piece of home with us, glowing softly in the distance. Because in the end, the moon's greatest truth isn't about its craters, its light, or its orbit. It's about us. It reminds us that we are not meant to stand still, that curiosity, courage, and wonder are written into our very nature. That every time we look up, we are seeing not just another world, but the reflection of our own endless potential. So when you see the moon tonight, that calm, familiar light cutting through the darkness, remember it's not just a rock orbiting the Earth. It's the story of who we were, who we are, and who we're still becoming. It's a reminder that we are small, but never insignificant. That we are fragile, but capable of greatness. And that even in the coldest, darkest corners of the universe, we are never truly alone. Because as long as the moon rises, humanity will keep looking up. And as long as we keep looking up, we will keep moving forward. The moon has been with us since the beginning, a witness carved from the same chaos that created our world. It has no voice, no warmth, and no heartbeat. Yet somehow it feels alive. It speaks to us in silence. It teaches us through stillness. It reminds us that even in the infinite dark, beauty can shine. Every generation has looked up at it and found something different. To ancient tribes it was a god. To poets it was a muse. To scientists it was a mystery. And now to explorers it's a destination. The moon has always been what we needed it to be, a mirror for our imagination. It reflects not just sunlight, but our own yearning, that unshakable need to go beyond. And maybe that's the real reason we've never stopped looking at it. Because deep inside we know we come from the same story. The moon was once part of us, torn away in the fire of creation. And ever since we've been trying to reach it again. That pull you feel when you see it glowing in the sky. That quiet ache. It's not just curiosity. It's memory. The universe remembering itself. Even now as we prepare to return, our mission isn't just about science or survival. It's about connection. About reaching out across the void and touching something that has always been ours. The moon is the first chapter of our future, the place where humanity will learn to thrive among the stars. It's the bridge between our home and infinity. And when our rockets rise again, piercing the black, carrying men and women toward that pale light, we'll be watching, just like we did in 1969. But this time it will mean something more, because now we understand the story. We know that the moon isn't just above us. It's within us someday. When you stand beneath a night sky far from Earth and maybe on Mars, maybe beyond, you might look up and see the moon as a tiny spark beside the distant sun. And in that moment, you'll remember that's where it all began. The first leap, the first dream made real. The moment humanity proved that the impossible was never truly impossible. Because the moon didn't change us by being mysterious. It changed us by making us reach. It forced us to think beyond what we knew, to question our limits, to believe that the stars were not walls but doors. And so the moon will continue to rise long after we are gone. Long after our cities fade. Long after our names are forgotten. It will keep orbiting quietly, faithfully, shining its borrowed light on whoever comes next. Maybe one day another civilization will stand beneath its glow and wonder who we were. The species that once looked up, dreamed big and touched the heavens. They'll see our footprints, our flags, our relics buried in lunar dust. And they'll know not just that we existed, but that we dared. And that will be our true legacy. Not the machines we built or the land we claimed, but the courage to look up and say, let's go. Because that's what the moon represents. Not the end of a journey, but the beginning of everything beyond it. The moon is eternal. The dream is eternal, and as long as we have both, we will never stop reaching for the stars. The moon was never the destination. It was the doorway. For centuries it called to us, not to stop but to start. Every footprint pressed into its dust was a promise, a whisper that humanity was ready to go further. And now more than ever that whisper has become a roar. The rockets that once carried us 250,000 miles to the moon are now being rebuilt. Stronger, faster, smarter, preparing to carry us millions of miles farther. Our next step is Mars, the red world, ancient and silent, waiting for us across the void. The same courage that took us to the moon will soon take us to another planet. The same curiosity, the same need to understand, the same flame that's burned since we first looked up at the stars. The moon taught us how to reach. Mars will teach us how to stay, but this is bigger than exploration. This is survival. For all its beauty, Earth is fragile. A thin oasis floating in a sea of emptiness. We've seen what happens when we take it for granted. Changing climates, rising seas, vanishing forests. The moon reminded us that worlds can be lifeless, barren, cold. Mars reminds us that life itself is rare. Together they are warnings and invitations. If we can learn to live on the moon, if we can build there, breathe there, thrive there, then we can do it anywhere. We can carry life into the darkness. We can become the universe's way of keeping itself alive. Every great frontier in human history began with a first step, crossing a river, sailing an ocean, breaking the sky. The moon was that first step into the cosmos. But now the horizon has moved. The same light that reflects off the moon shines across billions of stars, billions of worlds. Some may hold oceans, some may hold skies, and somewhere out there, perhaps, another moon is rising above another world, waiting for eyes that will one day look up and wonder too. And when we go, when humans finally travel beyond the moon, beyond Mars to the moons of Jupiter, the rings of Saturn, the distant ice worlds of Neptune, we'll take something more than technology with us. We'll take our stories, our memories, our lessons, our love for the little blue world that began it all. We'll take Earth with us, in every heartbeat and every dream, because that's what makes humanity different. We don't explore because we're lost. We explore because we belong everywhere. We are not content with standing still. We were made to wander. The same stardust that formed our bones formed the galaxies. The atoms inside us were born in ancient stars that exploded billions of years before we existed. We are the universe trying to understand itself. And so, when we build our first colony beneath the pale light of the moon, when the first human child takes a step in lunar dust, it won't just mark a technological victory. It will mark an evolution, the beginning of a species that no longer lives on one planet, but among many. Say, species that turned its gaze from its cradle and decided not to stop growing. The moon will always be there, our first light, our first teacher, our eternal companion. But beyond it lies an infinity waiting to be touched. The galaxies are calling. The stars are waiting. Someday, when humanity looks back from across the stars, from the edges of distant systems, we'll see the moon, a tiny grey pearl orbiting a blue gem, and we'll remember that's where the stars first opened their doors to us. We'll remember how it all began, with curiosity, with courage, and with the quiet glow of the moon guiding us forward. Long before we had telescopes or rockets, before we could even name the stars, there was the moon. It was the first light we ever followed, the first mystery that stirred something deep within us. When night fell and darkness swallowed the land, it was the moon that guided us, its glow painting silver paths across oceans, deserts, and forests. It was more than light. It was comfort. It was presence. It was hope. The moon has always been a mirror for human emotion. It has watched over lovers whispering beneath its glow, poets writing by its light, travelers lost and praying to find their way home. It has heard the songs of ancient tribes who danced in rhythm with its phases, celebrating the full moon's brightness and mourning the new moon's silence. For millennia, it has shaped not just our calendars but our hearts. It taught us about cycles, that endings are never truly the end, that darkness always gives way to light. In every culture, the moon has been more than rock and dust. It has been symbol, story, spirit. To the Egyptians, it was the god Thoth, the keeper of wisdom. To the Japanese, Tsukuyomi, the serene deity of the night. To the Native Americans, it was grandmother, the eternal watcher of the earth. And even today, when we know the moon's craters, its minerals, its orbit to the millisecond, we still feel that same quiet awe when we see it rise above the horizon. We may understand it scientifically, but we experience it spiritually. The moon connects us not just to space, but to each other. No matter where you stand on Earth, no matter your language or your beliefs, you see the same moon. The same glow that shines over a child in Tokyo touches the mountains of Chile, the deserts of Arabia, the forests of Africa. It's a universal constant, a thread that binds all of humanity together under one light. When you look up at the moon, you are never truly alone. Someone, somewhere is looking at it too. It also reminds us of time, not the ticking of clocks, but the breathing of the universe. The moon's phases are like the heartbeat of the sky. They taught us patience. They taught us rhythm. Every waxing moon is a promise of growth. Every waning moon is a lesson in letting go. It reminds us that change is natural, that stillness and motion, light and darkness, are all parts of the same eternal cycle. And maybe that's why we've always found beauty in it, because it reflects what we feel inside. The moon shows us that even in darkness there can be light. That beauty doesn't come from perfection, but from reflection, from being able to shine even when you borrow your light from something else. Just like the moon reflects the sun, we reflect one another's light in the darkness of life. Even as we send machines to orbit it, landers to touch it, and astronauts to walk its surface, Our relationship with the moon remains deeply human. It's not just about discovery. It's about recognition. We look at it and see the oldest part of ourselves, the part that still believes in wonder, still feels awe, still dreams. And so, when the rockets rise again, when human voices once more echo across the lunar plains, the moon won't just be another place we've reached. It will be a homecoming, the return of children to something ancient, something sacred, something that has always been waiting. The moon doesn't just light our nights, it lights our imagination. It whispers to every human heart, keep looking up, because in that simple act, in that one moment of lifting our eyes to the sky, we are reminded of what makes us human, the hunger to understand, the courage to explore, and the unending need to find meaning in the stars. So when you see the moon tonight, full, bright, silent, let it remind you of how far we've come, from the first fires to the first rockets, from wondering to walking, from dreaming to doing. And as it hangs there, still and eternal, know this, it will keep watching, it will keep glowing. And as long as it does, humanity will keep reaching, because the moon is more than a world, as it's a reflection of our spirit. And the spirit of humanity was never meant to stay on the ground. And now, as our journey comes to an end, the moon still hangs there, silent, distant, yet strangely familiar. It has watched over Earth since the dawn of time, through every rise and fall, through every life that ever looked up in wonder. The same light that touched the eyes of ancient hunters and poets now touches satellites, telescopes, and dreamers who refuse to stop asking questions. The moon hasn't changed, but we have. We began by wondering why we could never see its far side. We uncovered the science, the balance, the perfect rhythm of its motion, the delicate harmony that keeps one face always turned toward us. We learned that the dark side isn't dark at all. It shines under the same sunlight, hidden only from human eyes. We saw how gravity shaped it, locked it, and connected it forever to our planet. And yet, beyond all the science, we found something deeper, that the moon's mystery lives not just in the shadows it hides, but in the emotions it awakens, because in the end, this isn't just a story about space. It's a story about connection, about the invisible bonds that tie us to the universe. The same forces that hold the moon in its eternal orbit are the ones that pull us toward curiosity, wonder, and discovery. Just as the Earth's gravity holds the moon close, our desire to understand keeps us close to the unknown. Look up at the moon tonight and think about what it truly represents. A reminder that even when something seems still, it's always moving. Even when something seems distant, it's always connected. The moon is proof that beauty can exist in balance, that mystery and knowledge can coexist without destroying each other. The more we learn about it, the more we fall in love with its quiet presence. And maybe that's the real secret of the moon. Not that it hides its far side, but that it shows us how to look beyond appearances, how to search for what's unseen, how to accept that not everything must be revealed to be beautiful. Sometimes wonder exists because of what remains hidden. In the silence of the night sky, the moon continues its journey, turning, orbiting, keeping its gaze fixed on us. It has no voice, yet it speaks across the ages. It tells us to keep exploring, to keep questioning, to never stop reaching for the light. And as we continue to explore beyond it, to Mars, to the outer planets, to the edges of our solar system, we'll always carry a piece of the moon with us. It's our first companion in the cosmos, our eternal reminder of where our journey to the stars began. So the next time you find yourself beneath its glow, remember, the moon isn't just something to look at. It's something to understand, something to feel. It's a bridge between what we know and what we still dream of discovering, because every time you look up, you're not just staring into space, you're staring into the story of us. For billions of years, the moon has watched us from above, a witness to every sunrise, every storm, every moment of our existence. It has seen the birth of oceans, the rise of civilizations, and the quiet flicker of human dreams taking shape beneath its light.